Now we're going to study the change of bases for logarithms. Why do we use this? Because sometimes when evaluating a logarithm, we can see a relationship between the base and the argument, but it is not that easy to evaluate the logarithm, or just because simply there are logarithms like logarithm base 3 of 7 that there is no way to evaluate because there is no exponent of 3 in such way that 3 to an exponent gives me 7. So you want to evaluate it with a calculator. And calculators only have base 10 or base e. So if you want to evaluate a logarithm in a calculator, we need to change bases. So we're going to use two different examples in which we have to use a change of base for logarithms. And the formula is the following. If you have a logarithm that is base a and you want to change it to another base, let's say base c, then you have to do the following. The logarithm of the previous base of the argument is the same as the logarithm of the new base of the same argument over the logarithm of the new base of logarithm base new of the previous base. So let's apply this. If I want to use a calculator, as I said, I have to change to base 10 or base e. So I'm going to change one of each. So if I want to plug this into a calculator, I'm going to change it to base 10. So this means I'm going to apply the change of base formula by doing logarithm of my new base. Remember, base 10 is not written, never. So this is log of my argument over logarithm base 10 of my previous base. And this is approximate. If we plug this into the calculator, this is going to give us 2.44. Now, if I want to plug this into the calculator, but using base e instead, I'm going to use the following formula. Remember that logarithm base e is ln. So if I want to change from base 4 into base e, I'm going to write logarithm of my new base of the previous argument over logarithm of the new base, that is e, of the previous base. And if I plug this into the calculator, this is going to give me approximately 3.04. But what if instead of using it to evaluate in the calculator, I just want to use it to obtain exact evaluations of a logarithm where I know there is a relationship between the argument and the exponent, but I'm not quite sure how to find the solution. Let's see at the other set of examples. In this one, we know that 64 and 32 have something in common. They are both powers of 2. So if I change this logarithm into base 2, I can have a much better comprehension of what the result of this logarithm could be. So I'm going to change into base 2. So by applying the formula, this is logarithm of my new base, that is 2, of the previous argument over logarithm base 2 of the previous base. In this way, this is way easier to evaluate because we know logarithm base 2 of 32 is 5. Why? Because 2 to the power of 5 is 32. And then logarithm base 2 of 64 is 6 because 2 to the power of 6 is 64. So the answer for this logarithm is 5/6. For this second one, we know that the relationship between 49 and 343 is that they are both powers of 7. So to evaluate this logarithm, I can change it to base 7. So I'm going to do this by applying my formula, that is logarithm of my new base of this argument over logarithm new base of the previous base. Here, it's easier to evaluate because you know that 7 to the power of 3 gives you 343, and 7 to the power of 2 gives you 49. So the result for this logarithm is 3/2. This third exercise, you know that 27 and 9, again, they have a relationship. Both of them are powers of number 3. So I can change this into base 3 by applying the formula is logarithm of the logarithm new base of the same argument over logarithm new base of the previous base. And this is 3 to what power gives me 9? 2. 3 to what power gives me 27? 3. So the result for this logarithm is 2/3. This one, 25 and 125 are both powers of 5, so I can change this into logarithm base 5 of the new base of the argument over logarithm new base of the previous base argument of the previous base. So 5 to what power gives me 125? 3. 5 to what power gives me 25? 2. So the answer for this logarithm is 3/2. Lastly, you know that 1/6 and 36 are both powers of 6. So we can change this into powers of logarithms of 6. So logarithm of the new base of the new argument of the argument over logarithm new base of the previous base. 6 to what power gives me 36? This is 2. And 6 to what power gives me 1/6? This is -1. So 2 over -1, this is -2. So this is how you apply change of base for logarithms.